guys, today we're going to be learning how to graph a new kind of function. So we have been graphing a lot of lines, and today I'm going to show you how we're going to graph things that look like this, that are curves. We call them quadratics, and the shape is called a parabola. But before we get into all of that, let's just see what they look like. So here in Desmos, we're going to go to our graphing calculator. And remember, we like to change the settings because we don't like those little minor grid lines, and we like to count by ones. So now that our graph's set up, let's go ahead and graph our regular old line, y equals x, okay? And we've graphed these enough times, we know that that's a line in there. If I go to my settings and turn on my table, I can see that my table of values, -2, -1, 0, 1, 2, gives me all those same values plotted there. Okay, well, we're not here to talk about lines. We're done with lines. What we want to talk about is what happens if it's not just x, but what if it's x squared? Squared means an exponent that's up to the 2, and I did that by doing the little caret button above 6 to get to my square button. But now, okay, look at what happened over here. I don't have a line anymore. I've got a quadratic function, and it's shaped like a U. It's curving. So when I look at my table of values, and I go ahead and click on my settings, open up my table, I'm going to see that I've got a very different pattern here than a line. It's almost like it repeats, because whatever happens on one side of the curve happens on the other side of the curve. And just as a reminder, when you have something squared, it just means that number times itself. So -2 times -2 is 4. That's how we'd get that value. 1 squared would be 1. 2 squared is 4. If I typed in 3, 3 squared would be 3 times 3, which is 9. And look, I can even see that plotted up here on my graph. And I could keep going, but I don't need to. We know how to square numbers. So we can see our first major difference between a line and a quadratic is that our pattern is different in our table. Also, it's definitely not a line. It goes 2 directions. It goes down and up, not just one way. So I'm going to go ahead and clear out our line for a second. And I want us to actually look at another example of a quadratic. So you don't just need 1x squared. I could have, say, a -x squared. Look what happens there. It's flipping the graph upside down. But I also could add even more things on there. So I could say, -x squared minus 8x minus 15. And look, I still have a parabola, a quadratic. It's just upside down and moved over. If I go to my table of values here, and let's go ahead and change the color too, so it's not the same color. Let's make it red. If I change my table here, I'm going to start seeing, okay, I've got 1 point here, and all of these big values here. Now, how did I get those values? Well, I'm just taking the x value and plugging it in. But there's some important things I want us to look at when we're talking about a quadratic function. Right here at -5, 0, and here at -3, 0. That's where our parabola crosses over the x-axis. And we could even put those in our table over here. So -5, all right, let's type in -5. Ta-da! We have an x-intercept, just like a y-intercept, but where it crosses the x-axis. And I can do the same thing with -3. So if I plug in -3, there we go. It's plotted right there on that axis. And then one of the most important characteristics of a quadratic is this mountaintop right here. That's what we call the vertex. And that's where a parabola changes from going up to going down. Or if it's the other way, from going down to up. And again, I could put that in my table right here. So that's -4. I could put in -4, and I've got that right there. And it still has our favorite thing, the y-intercept. I just have to scroll down a little bit to get it. So I'm going to scroll, 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 scroll. Look, there it is, right there at 0, -15. So it has some similarities to lines, but it has some very unique things. So let's actually talk about a couple of those pieces of vocab. So first of all, what is a quadratic function? A quadratic function has an x squared as the highest x value. Sometimes it can also have an x, but it has to have an x squared. And this is different than a linear function because linear functions are only x's. So mx plus b, no x squareds. And there's a little example right there of what a quadratic function might look like. The shape of a quadratic function. We talked about this. It's a U. Looks like this. We call this U a parabola, unlike a linear function, which is a line. So linear functions are lines, quadratic functions are U's. But remember, it could also be upside down. So it could be a U, or it could be an upside down U. So we could call it an up like a cup or down like a frown. But it's always going to be a U, just either positive or negative. Next, the point where the parabola crosses the x-axis is called roots, x-intercepts, zeros, or solutions. I know, there's a lot of vocab here. All four of those things mean exactly the same thing. And some different areas will use roots, some might call them x-intercepts or zeros. All of those words mean the same thing. And what do they mean? It's these right here, the stars. Where does the parabola cross over the x-axis? So, maybe it would cross here and here. Maybe if it goes the other way, it crosses here and here. Maybe it only touches once, or it could even be floating in air. Sometimes there's not any. And lastly, the most important part of a quadratic is the vertex. And the vertex is where the parabola will change direction. So it's the top of the mountain, if it's going like this, or it's the bottom of the valley, down here, okay? So now we've talked a little bit about what makes quadratics unique, and we have a little bit of vocab to talk about characteristics. So now let's start graphing.